Hello everyone, I am NP Deepak, Assistant Professor, Department of Mathematics, SNS College of Technology, Coimbatore. Next today we are going to discuss on Initial Value Theorem and Final Value Theorem. Initial Value Theorem means if the Laplace transform of f of t and f of t exists. If the Laplace transform of the function f of t and f dash of t exists means L of f of t is equal to f of s, then limit t tends to 0, f of t is equal to limit s tends to 0, s into f of s. These two LHS and RHS satisfy means initial value theorem is verified. Next we are going to see final value theorem. If the Laplace transform of the function f of t and f dash of t, if the function f of t and f dash of t exists and L of f of t is equal to limit s tends to 0, s into f of s. If these two conditions satisfy, LHS is satisfied, then the final value theorem is verified. Next we are going to see problems on initial value theorem and final value theorem. First problem, verify the initial and final value theorem for the function f of t is equal to 1 plus e power minus t into sin t plus cos t. So first we can take the function f of t is equal to Laplace transform L of function f of t is 1 plus e power minus t into sin t. Multiplying the e power minus t inside, so 1 plus e power minus t into sin t plus e power minus t into cos t. So the function f of s is L of 1 plus e power minus t into sin t plus e power minus t into cos t. We can split the terms. So Laplace transform of 1 plus L of e power minus t into sin t. Before video we have seen the first shifting property. Here e power minus t means we have to replace s tends to s plus a. Here a is nothing but 1, so s tends to s plus 1. Here also a is 1, so s tends to s plus 1. Laplace transform of e power minus t into cos t, replacing s tends to s plus 1. So Laplace transform of 1 is 1 by s plus Laplace transform of e power minus t into sin t is 1 by s square plus 1, replacing s tends to s plus 1 plus L of e power minus t into cos t value is s by s square plus 1, replacing s tends to s plus 1. So 1 by s plus 1 divided by replacing s in terms of s plus 1. So 1 divided by s plus 1 the whole square plus 1 plus s plus 1 divided by s plus 1 the whole square plus 1. Finally we get 1 by s plus s plus 1 plus 1 s plus 2 divided by the a plus b whole square identity we are splitting, so s square plus 2s plus 2. Next we have to find s into f of s. So multiplying this function with this, so s into 1 by s plus 2 divided by s square plus 2s plus 2. Next we find in the initial value theorem. So initial value theorem statement for verification is limit t tends to 0, f of t is equal to limit s tends to infinity, s into f of s. So first we have to take LHS. So limit t tends to 0, f of t. So limit t tends to 0, f of t is 1 plus e power minus t sin t plus e power minus t cos t. So applying the limit t tends to 0 in the function. So 1 plus e power minus 0 sin 0 plus e power minus 0 cos 0. So e power 0 is 1, sin 0 value is 0, so 1 into 0 is 0. 1 plus 0 plus e power 0 value is 1, e cos 0 is 1, so 1 plus 1, 2. So left hand side value is limit t tends to 0, f of t is equal to 2. Next we have to prove the right hand side, limit s tends to infinity, s into f of s. So limit s tends to infinity, s into f of s is s into 1 by s plus 2 divided by s square plus 2s plus 2. Replacing that, so limit s tends to infinity, multiplying s inside, so s by s is 1 plus s square plus 2s divided by s square plus 2s plus 2. So limit s tends to infinity, 1 plus s square plus 2s divided by s square plus 2s are getting common, so s square plus 2s into 1 plus 2 divided by s square plus 2s. This s square plus 2s s square duplicate cancel, we get 1 plus 1 by 1 plus 2 divided by s square plus 2s. Applying the limit we get 1 plus 1, so limit s tends to infinity, s into f of s is equal to 2. So LHS we get limit t tends to 0, f of t is equal to 2. Right hand side also limit s tends to infinity, s into f of s is equal to 2. For hence initial value theorem is verified. Next we are going to prove the final value theorem. Final value theorem condition is limit t tends to infinity, f of t is equal to limit s tends to 0, s into f of s. First we taking the left hand side. So limit t tends to infinity, f of t is equal to limit t tends to infinity, f of t is 1 plus e power minus t sin t plus e power minus t cos t. So applying the limit t tends to infinity means 1 plus e power minus infinity into sin infinity plus cos infinity. Sin infinity cos infinity is 0. So 1 plus 0 will get 1. So limit t tends to infinity, f of t is equal to 1. So left hand side value limit t tends to infinity, f of t will get value as 1. Next we have to take the right hand side, limit s tends to 0, s into f of s. S into f of s we have find s into 1 by s plus 2 divided by s square plus 2s plus 2. So limit s tends to 0, s into f of s is equal to limit s tends to 0, s into 1 by s plus 2 divided by s square plus 2s plus 2. So multiplying s inside, so 1 plus s square plus 2s divided by s square plus 2s plus 2. Applying the limit s tends to 0, so 1 plus 0 divided by 0, I get 0, so 1 plus 0, 1. So limit s tends to 0, s into f of s is equal to 1. So limit t tends to infinity, f of t is equal to limit s tends to infinity, s into f of s is equal to 1. Final value theorem also proved. Hence, initial value theorem and final value theorem has been verified for the function f of t is equal to 1 plus e power minus t into sin t plus cos t. Thank you.